Today we are going to talk about indices and logarithms, and we are going to focus more on laws of indices. On our introductory part, we will learn everything you need to know about the laws of indices. You will learn how to multiply indices, divide indices, how to use raise values of the power of 0 and to the power of 1. We also have some objectives that we're going to finish in this lesson. And by the end of the lesson, you, the learner, should be able to state the laws of indices regarding multiplication of indices, state the laws of indices regarding to zero index. We are going to state the laws of indices regarding to division of indices. Also, we shall continue to have the laws of regarding to negative indices, state laws of indices regarding to fractional indices, apply the laws of indices in calculation. Yeah, we're going to have some good examples that you are going to calculate using this lesson of indices, especially the laws of indices that we have discussed. So, at the beginning of our class, what are indices? An index or power, yeah, index is also known as power, is used to show that a quantity is repeatedly multiplied by itself. Basically, there are shorthand way of writing multiplication of the same numbers. Now, in this lesson, we shall see that suppose we have this example here, 4 multiplied by 4 multiplied by 4. There's a simplest and shorter way that we can use to write this expression. Instead of writing 4 multiplied by 4 multiplied by 4, we can use a shorter way to write this, to represent this information here. We write this as 4 to power 3. As you can see, 4 is raised to power 3. So 4 multiplied by 4 multiplied by 4 is equals to 4 power 3. The number here 3 is called power or index. Note that the plural of index is indices. That's why you can see we are talking about laws of indices. As you can see here, this 4 multiplied by 4 multiplied by 4 is simply written as 4 raised to power 3, where the 3 number there is the power or the index. Now, this can be done with letters as well as numbers. Yeah, that's the important part about mathematics. We are not only talking about numbers alone. We shall also talk about letters. So we might have an example like A multiplied by A multiplied by A multiplied by A. As you can see, we have 5 A's there. The same A is multiplied to itself 5 times. Since there are 5 multiplied together, since there are 5A's multiplied together, we write this as 2 power 5. That is A power 5. As you can see here, we have A power 5 here. We have A power 5 here. This 5 now is our index or power because A is multiplied to itself 5 times. So A multiplied by A multiplied by A multiplied by A multiplied by A is A raised to power 5. We usually say raised to power 5, but A power 5, where 5 is now the index. When you're talking about index, let's say we have an expression A n. This is explained, can be defined as A raised to any power number n. This is a number that is raised. This is now what we call an index or a power. For example, n can be 1, 2, 3, 4. In expressing this equation, we can say that a power 1 is equals to a power 2 is equals to a multiplied by a, and a power 3 is a multiplied by a multiplied by a. We can show that a power n is a multiplied by a multiplied by a multiplied by a up to any number, up to n, a power n, where n can be any whole number. When using this, in short, what can we say what an index is? An index or a power is used to show that a quantity is repeatedly multiplied by itself, as we see here. Repeatedly multiplied by itself. A power 3 is a multiplied by a multiplied by a. Now, as you have seen there, our indices that we have multiplied a into 5 times, and now it brings, now the simplest way to write that a multiplied to itself 5 times is a power 5. And you have seen that indices are the number that used to represent how numbers are multiplied to itself, how many times they can be positive, they can be negative. It all depends on how it comes. Now, we are going to talk about the laws of indices. Laws of indices provide us with rules for simplifying calculations or expression involving powers of the same base. Now, powers of the same base, meaning the same base, for our example there, it was A. Now, the same base being A can be multiplied as many times. You say maths can have calculations at a point where you have many numbers and some numbers are equal. So the shortest way, instead of writing all of them, we can write a power 5. That's why you're saying laws of indices provide us with rules for simplifying calculations or expressions involving power of the same base. This means that the larger the number or letter must be the same. Now, example, 2 raised to power 5 multiplied by 2 raised to power 3. Instead of writing 2 times 2 times 2 times 2 times 2 up to 5 times, then multiplying by 2 times 2 times 2 times 2 3 times, we can write 2 raised to power 5 multiplied by 2 raised to power 3. As you can see here, these are our indices here. Now, 2 raised to, multiplied by 2, 2 raised to power 5 multiplied by 2 raised to power 3, we see it's 2 raised to power 8. Even we have division. 10 multiplied by x power 10 divided by x power 4 give us 10 power 6. We shall find how we get these numbers here. We shall know how. They are even more simplest way to find these. Now, we cannot use laws of indices to evaluate calculation when the bases are different. You see, these laws of indices, as the definition of index says, index is a number representing an expression how many times it has been multiplied to itself. Now, different bases means that you cannot use a number 3 and 2 and then you say that laws of indices can appear there. No, we cannot use there because, now let me give you this simple example here. 2 power 5 multiplied by 3 power 3. Now here we have two different bases. Now the laws of indices cannot be used here because of the difference of the base. And 10 x raised to power 10 divided by y raised to power 4 cannot be used because of the different bases. But we can, however, evaluate this calculation by solving them individually. Now, maths has always have answers. That's the funny thing. Now, because of the bases that cannot be the same, it doesn't mean because laws of indices don't apply there, the question is done. No. Because of here, if the bases are different, we solve them individually. For example, 3 raised to 2 plus 4 raised to 2. This is 9 plus 6. 3 raised to 2 is 9 plus 4 raised to 2 is 6. That's how we use different, if we have different bases. And the answer you are going to get is 25. Now, let's begin now on the laws of indices, our main topic of the lesson. What are the 5 laws of indices? Number 1, we have the laws of indices are multiplying indices, dividing indices, we have bracket with indices, we have power of 0 indices, we have negative indices. In this lesson, we are going to focus on these five laws of indices, even though there are many others. Different laws of indices. But in this lesson, we are going to discuss only 5 laws of indices. 5 laws. Namely, number 1, we have multiplying indices. When we are talking about multiplying indices, we know that, or for example, we have the same base, A. And we're talking about multiplying indices, A power 3, you multiply by A power 2 is A power 5, which can be expressed as A multiplied by A, multiplied by A, multiplied by A, multiplied by A. 1, 2, 3, 4, 5. A power 3, and then A power 2, which is in total of 5. What are we trying to say? When generating this formula, we can say that multiplying indices shows that A power n plus A multiplied by A power n is equals to A m plus n. The second law we are going to talk about is dividing indices. When talking about dividing indices, we are going to say that, for example, we have A power 3, you divide it by A power 2. What do we get when we divide this? When talking about division, simply in coming to these powers, we minus them. It's the difference between this and this. Let's say A multiplied by A multiplied by A, you divide by A multiplied by A. This one cancels, which is equals to A. This derives us to this formula showing that A power n, you divide by A power n is equals to A power n over A power n, which shows that A power n minus n. This is A power n, you divided by A power n. It will give this formula. Now this formula is what you are using in the division, the dividing indices. The third law we are going to talk is laws which involve brackets. We usually call them bracket indices. As you know, bracket indices let's show, for example, an expression a power m into bracket n. Let's say m is equals to 2, n is equals to 3. What can we show here? A power m power 2 is raised to power 3. This is the same as a squared multiplied by a squared multiplied by a squared, using the laws of multiplication. But how many here it is? Counting using the law of multiplication, we have 2 plus 2 plus 2, which is a power 6. What do we show here? Here we know that a m power n can be shown as a m times n. Now, this is the formula that you are going to use in the bracket indices. And the next we are going to talk is the fourth law. We are going to talk about zero, indices of zero. What are we talking about here? For example, we have a number a power 0. Anything you adding to 0 usually remains the same. This shows that a power 0 is the same as 1. This is the law of indices of 0. Any multiplication, any number raised to power 0 is 1. And the last law we are going to talk in this lesson is negative indices. Negative, as the word negative indices, you usually have a negative sign in an expression. What do we say about this expression? Negative sign in an expression. A power negative m. Now, when we are talking to this number here, to negative power m, we usually say it is the reciprocal. This number shows reciprocal. For example, a power negative m is a 1 over a power m. To make this number positive, this expression is the reciprocal of this, using negative indices. So in short, negative indices usually shows reciprocal of numbers. Now, as you have seen, we are going to discuss 5 laws here, and you have seen the laws, how the formulas come about around. Now let's go to talk about each of them individually. And first, we are going to talk about multiplying indices. As you saw, multiplying indices is our first law. When multiplying indices, with the same base, add the powers. That is, a raised to m multiplied by a raised to n is a m plus n. As you have seen here, add the powers. The powers are m and n. That's how the multiplying indices is. But one thing you should always remember, multiplying indices have with the same base. The base must be the same. For any number that is going to apply this law, the base must be the same. That's why we say a power m multiplied by a power n give us a m plus n, because we add the powers. Let's do an example of each and every law. Law number 1, which was the multiplication law. As we recall the formula was a power m multiplied by a power n is a m plus n. Let's do a simple example.
For example, A is 4 and n is 3, n is equals to 2. Using this expression, a power n multiplied by a power n is a power 3 multiplied by a power 2. As you see, we have replaced m and n with these values that we have here. What does it show? Let's use this first expression. A power 3 is a multiplied by a multiplied by a. This is 3. And then you multiply it by this a, which is raised to power 2. A multiplied by a. How many a's do we have here? 1, 2, 3, 4, 5. This shows us a power 5. Replacing a with our 4, we see that 4 multiplied by 4 multiplied by 4 multiplied by 4 multiplied by 4 is 4 power 5. This 4 power 5, this 5 is the number of repeated times 4 has been multiplied. We can have another example where a is equals to 2x and m is equals to 2, n is equals to 3. Let's use this example here. So our expression, our question can be question. Find 2x power n times 2x power n. How can we do this? Using this expression, we replace m and n with the values we have. 2x power 2, you multiply by 2x power 3. What do we have here? We can say is 2x multiplied by 2x, you multiply by 2x times 2x times 2x. Here we have 2x's and 2x we have here as 2. Counting all of this, it will give us 2x power 5. But you cannot leave our question like this way. Finishing here, we can say that 2 power 5 is 32. And x power 5 will remain, because x is unknown, it will remain x power 5. What will be our answer? Now our answer will be 32x raised to power 5. This is the answer that you are going to use here.
Now, you have seen how we have done the multiplication with the multiplying indices. Now, the law number 2 that you're going to discuss is dividing indices. What do we know more about dividing indices? When dividing indices with the same base, subtract the powers. You remember the multiplication one was addition of powers. Now, when we come to division of indices, dividing indices, we see that we subtract the powers. For example, a power m divided by a power n, it will give us a m minus n, because m, using division, we subtract the powers. Here we see there's a subtraction sign, and m is minused to n because of the division of indices. Remember, the base must remain the same. Now, let's see for example.
The second law we are going to talk about is the dividing or the division law. What do we know about the division law? As we talked earlier, the formula for the division law is a power n. We divide by a power n, we get a power n minus n. Now, this is our main formula. Now, let's express this formula into simple terms using examples. What do we know about examples? Given by a power 7, you divide it by a power 3. This can be written as a power 7 divided by a power 3, which is expressed as a times a times a times a times a times a times a. Divided by a times a times a. A power 7, it means a is multiplied to itself 7 times. 1, 2, 3, 4, 5, 6, 7. And a power 3 is multiplied to itself 3 times. Now, using our law, which we know that m minus n, let's see if it will get the same answer. When you cancel in 3, 3. How many a's are remaining? 1, 2, 3, 4. Our answer is a power 4, which simply proves that using our equation a power 7, you divide by a power 3, can be written as a power 7 minus 3, which is a power 4. Now, this is the answer we are going to get after dividing our equation. You see, using this formula, we get this answer. Now, another example. Example 2. Let's use 3y and a being our a and m being our 2, n being 1. What can we say about this? Knowing the formula, we use the formula 3y power n minus 3y power n. What do we have? 3y power 2, you minus 3y power 1. You divide. So for that, we are dividing because we are using the division law. What do we have here? 3y multiplied by 3y, you divide by 3y. This one cancel this one. We remain with 3y. You have seen we are remaining with 3y. This shows that 3y divided by power 2 divided by 3y power 1, we get 3y 2 minus 1. Are you seeing it? 3y 2 minus 1, which is 3y power 1. Now, the answer is good. Now, this is the division law.
Now, what is our third law? Our third law is bracket with indices. Now, what do we know here? When there is a power outside the bracket, multiply the powers. For example, a multiplied by n is equals to a power m into bracket raised to power n is equal to a multiplied by m power m multiplied by n. Now this is what we're talking about, bracket indices. Now this is our main formula here. A power m into bracket raised to power n is equals to a m times a. As you can see, m is in bracket. So m multiplied by n is when we use the bracket law of indices. Remember, the base must always be the same.
We are going to talk in the third rule, which is indices with brackets. When we have indices with brackets showing, our main formula shows that a power n gives us a m multiplied by n. Now, this can be shown easily using an example. Let's use an example. You have been given in an exam a question 2 power 3 squared. What does this show? This shows that 2 power 3 is multiplied to itself 2 times. 2 power 3 multiplied by 2 power 3. Using the law of multiplication, we saw that numbers with the same base raised to powers when multiplied, it means the powers are added. Saying 3 plus 3 is 6. Our answer is 2 power 6. It is easy saying that 2 power 3 power 2 can be given as 2 3 times 2, which is 2 power 6. Now, this is the
Now, you have seen that's the bracket power. Now let's go with the fourth law, which is power of 0. That means that any number which is raised to 0. Any non-zero value raised to the power of 0 is equal to 1. That is, a power 0 is equals to 1. Any number, no matter the value, as long as it is a non-zero number, as long as it has any content raised to power 0, the answer will always be 1.
Now, let's see the fourth rule. The fourth rule is power 0. Any number raised to power 0. Now, our formula shows that a power 0 is equals to 1. How is this shown? We can say that, example, a power 3 divided by a power 3. What does this show? Using the division law, it is a 3 minus 3, which is equals to a power 0, 1. Let's show in a very simple way for you to understand. A power 3 is a multiplied by a multiplied by a. We divide by a multiplied by a multiplied by a. By this 1 times 1 times 1 is 1 over 1, which shows the answer is 1. That's why we say any number raised to power 0 is 1. Let's use another example. Instead of using letters, now let's use numbers. Example 2. 2 power 3 divided by 2 power 3. What do we know here? It is 2 multiplied by 2 multiplied by 2. You divide by 2 multiplied by 2. Check. When cancelling this, all of this is 1, 1. Our answer remains as 1. This simply shows that any number, let's say 2 power 0 is 1. 1000 power 0 is 1. And let's say even a half, when let's say a fraction, power 0 is equals to 1. Now, this is the fourth rule. Any number raised to power 0 will eventually give us 1.
Now, our fifth law that we are going to talk about is negative indices. What do we know about negative indices? When the index is negative, put it over 1 and flip, write its reciprocal to make it positive. That's how we write numbers. That's why it is the reciprocal of a number. That is a power negative m is 1 over a power m. In summary, what have we talked about? We have talked about indices, which are numbers showing how many times a number has been multiplied to itself. They are usually called index or power. And we have talked about laws of index. And we know that index can be used to simplify expressions which involve same base. And laws can be applied to any number as long as the base is the same. For example, here we can see that 2 raised to power 3 is 2 multiplied by 2 multiplied by 2, which is 8. Means 2 power 3. 2 power 2 is 2 multiplied by 2, which is 4. 2 power 1 is 2 multiplied to itself as 1. 2 power 1 is the same as 2, which will give us 2. 2 power 0, as we said, any number multiplied to 0 is 1. Any number powered to 0, that is not multiplied, that is powered to 0 is 1. And a number which is raised to a negative index, it means you should do the reciprocal. That is 1. Like here, 2 power negative 1 is 1 over 2, which is 0.5. 2 power negative 2 is 2 a half squared, which is a half multiplied by half, which is equals to 0.25. And here 2 power negative 3 is 1 over 2 is equals to a half multiplied by half, a half multiplied by half, which is 0.125. What are the real life situation indices? What are real life situation of indices? Real life situation of indices provide us with rules for simplifying calculations or expressions involving powers of the same base. Here, we know that we see that indices are used in computer game, physics, pH, and Richter measuring scale, engineering, economics, finance, and many